Hey, Vlad here from devinsight.com. Welcome to another video. In the previous couple of videos, we focused on the success and the error channels, and it turns out that ZIO adds yet another layer that can be used to inject dependencies into your ZIO. It's important to understand that you don't need to use it if you don't like it. In fact, I'm not a huge fan myself. Once we're going to get to the portion of the series where we're going to rewrite the tagless final to do up into ZIO, we're actually not going to use it. It's worth learning though, so let's roll the intro and have a look. While you were gone, I actually updated some dependencies. Let me show you the diff. So Scala FMT 30RC4 came out, and Scala 3.0 actually finally came out. I also added a flag over here that, just in case, because I forgot to add it. I always try to keep my my projects up to date even when I'm recording videos. I have no idea how this happened that I added the test dependency instead of the regular ZIO, and also 0.9 also already came out. What else do we have? Just Scala test and Scala check, doesn't really matter. Okay, SBT came out. Scala came out to 12.14. Nothing really major. In fact, let's also remove the Git directory. I only use Git when I want to show you some very specific changes, so we're not going to need it. In fact, once we're going to finish writing this homegrown version of ZIO, I'm simply going to upload it as a gist, and then you guys can have a look. I also noticed that in our ZIO over here, where we're using an object, our ZIO, we actually don't need it. In fact, it's actually kind of cool with this colon over here. I'm going to remove it right now, and Scala FMT is going to indent everything properly. With the curly brace syntax, I would need to go down to the bottom of the file and remove the curly brace. Over here, I actually don't need to. Okay, so now we can switch between our ZIO and the regular ZIO simply by having, either having the import to ZIO or not. So this one is the real ZIO and this one is our ZIO. Two more tiny changes before we finally start hacking on the reader channel. We used the format off and format on, so I know that it's going to be formatted badly. In fact, let's actually remove this because it's probably going to be messed up in the future as well. So let's have this, and I'm going to have curly brace over here and curly brace over here. It's gonna look much better. And one last thing is that we're using a case class for ZIO, and there's actually no need to do this. In fact, case classes were commonly abused in Scala 2 because they provide the factory method, so you don't need to write the new keyword. And in Scala 3, you actually don't need to write the new keyword in many occasions, like in this one. So I'm simply going to remove the case over here. So it's simply going to be a final case, but we're accessing the thunk, so I have to make it a val like this, okay? And everything else still compiles, right? So over here, we don't need to say new. In fact, we even saved on some characters. All right, let's finally talk about the third and the most complicated channel. It's going to be probably the most mind-bending, I wanted to say originally video, but it's actually going to be 5 videos dedicated to reader channel. Imagine that, right? We have one video for the success channel, one video for the error channel, but we're going to have 5 videos for the reader channel. In fact, I strongly believe that in ZIO, they kind of went overboard with this. I actually don't believe that the benefits outweigh the complexity costs. As I already mentioned, it's not a big problem because you don't have to use it. However, if you want to write some idiomatic ZIO code, then it's still worth learning about. So if you're still here, let's get right to it. This third channel is related to dependency inversion, and there are 2 ways to implement dependency inversion. One is dependency injection, nothing fancy. You basically have constructors and you pass your dependencies along and call it a day. And the other one is called the service locator pattern. It's not very common to use these days, and its functional incarnation is called the reader monad. So what we're going to do now is we're going to set up a very, very simple example. We're going to start with the regular dependency injection, then we're going to convert it to the service locator pattern, and we're not even going to use either ZIO or the reader monad. All right, so let's go to main and let's actually comment out this whole thing. Okay, so what we're gonna have is we're gonna have a trait and we're gonna call it business logic, right? So it's gonna mimic like a proper application. Okay, so it's gonna have a function. Does Google have even amount of pictures of, and we're gonna have a topic. It's gonna be a string, and it's going to produce a Boolean. Very simple trait. At the bottom, it's going to say that we don't have a main method. Maybe we should switch just to compilation, okay, so that it's less confusing. Okay, simple trait. We're going to have an object. We're going to call it business logic. All right, it's going to have make Google, which is a very common pattern. It kind of started with tagless final to not to have a class that implements some trait, but instead to have like this kind of like factoring method kind of thingy. Okay, so we're going to say new, and we don't need to annotate the type. In Scala 3, it's going to be in first for us, and we're going to say override. And I believe as of right now, metals can actually not generate this for me, so I need to copy paste it like this. Okay, so what it's going to do is going to go to Google, and it's going to count pictures of topic right? So some integer is going to come out. It's going to do modulo 2 equals 0. Okay, so where does Google come from? Well, it's just a trait, Google, and it's going to have this function over here, right? This one. Okay, it's simply going to get a topic, string, and it's going to produce an integer like this. Very, very simple code. Now let me scroll down a little bit. So we're going to have object, we're going to have Google implementation. And by the way, it's very important that I don't call it Google like this, because even though we could have a companion object for Google, usually in the real application, this would be in a very different submodule. And over here, like usually I would set up a proper SBT multi-build for you guys. But in this case, I wanted a really, really easy way to switch between the real ZIO and our ZIO, so I can control it with this one import. So I have to throw everything into the same file. Okay, so I'm going to say Google impl just to denote the fact that it should actually live in a completely different submodule. It also is going to have a make, but since it doesn't need any params, we're going to make it a val. And recently I started making them lazy vals. All right, Google like this. Okay, so we're going to do a new. The type is going to be inferred for us. We're going to do override. We're going to grab this thing over here, throw it in there. Okay, it's going to produce an integer, and we're simply going to say if topic equals cats. Then we're going to produce 1337, else 1338. Now, usually you would also have a way to deliver your application, for example, via HTTP or via the terminal. But since it's such a basic example, we're simply going to go to main, right? So we're going to skip this layer, and it's going to become very, very important in the upcoming videos. Okay, so over here, we're going to have an object called dependency graph, and I kind of hate that it positions it like this. Okay, so this is where we're going to assemble the entire dependency graph. It's also going to have a make, right? It's going to produce business logic. Like usually it would produce something from the delivery layer. I usually call it controller, but in this case we don't need it. So we're going to go business logic, make Google implementation dot make like this. Very, very simple. And now we can finally arrive at our object main over here, extend scala app. Okay, so we're going to finally produce a business logic by going to the dependency graph, and we're simply going to make it. Okay, now we're going to print out. I'm actually going to steal my favorite hyphens from over here. Go down like this, print line like this, like this. So it's not even functional yet, right? Doesn't matter as of right now. Okay, so auto completion. There we go. Cats. And over here, we're going to do dogs. And now we can finally start running this thing. Run. So as you can see, for cats it's false, and for dogs it's true. And this is going to be the example that we're going to run with in the upcoming 4 or 5 videos. Let me also spell out the dependency graph part for you guys. It's going to become important or even evident why we're doing this in the upcoming videos. So we're going to do Google equals google.make. Okay, we're going to have business logic equals business logic dot make Google, and then we're returning business logic. Okay, so this is this one line, just like spell out like this, right? So this has to be Google implementation. There we go. Okay, creating Google, creating business logic, combining them together, returning business logic. This is the dependency graph. Now, this line over here is the classic dependency injection, right? So we have some abstract definition of Google, okay, and we're injecting it into the business logic. Okay, the other way would be the service locator way, that you would either have some magic ether or some global object called service locator, and it's going to have methods like, you know, locate service, and you are going to give it a string, which is probably going to be a class name, and there's probably going to be some reflection involved to actually locate the instance of this class. Now, dependency injection or testing, injecting fakes is a bit harder with the service locator if you use a global object. So usually instead it's kind of mixed with dependency injection. So you kind of like inject the service locator into the business logic, and then this instance is used to locate your classes. And then when you're writing your test, you could inject the fake version of the service locator, the one that is going to locate the fake instances. In function programming, it's much, much simpler. It's simply a lambda. So we're going to go up over here where we construct the business logic, and we're going to have a lazy val over here. And in ZIO, it's kind of convention to call them live. Okay, so, and it's simply going to be a function. It's going to say like, hey, assuming that I have Google, I'm just going to produce a business logic. Okay, so how is it going to do it? Well, it's just going to call make, right? It's going to call make with Google, right? In fact, we could use array expansion over here. The error message is actually wrong. We just simply need an equal sign over here. Okay, so in fact, we could even use array expansion over here, right? We could simply say make, but I'm going to spell it out for now. In fact, maybe I'm going to position it like this. Okay, so the difference now is that before you could not create a business logic without providing Google. Now you sort of can, right? You can call this live thing. It doesn't have any params, and it's going to give you a function that, given Google, it would work. So it's kind of like it introduces like yet another level of indirection, but it's kind of the same thing. By the way, guys, from now on, I'm going to start asking you to actually like the video. I've been doing this thing for 4 years, and it took me 4 years to reach 5,000 subscribers. I'm not saying it's your fault. Obviously, it's partially mine. But if you could just click this one tiny button, it's going to help the algorithm out, and then everybody's going to be happy. Thanks. Now, let's actually go to the business logic dependency graph, and we're going to have a lazy val live. And because Scala is such a phenomenal language, not much is actually going to change for us. Okay, so for now, we're sort of like mixing and matching. We're kind of slowly getting there. But for now, the implementation is going to be exactly the same. Now, before, I simply called make, and I could do the same thing over here. But for this particular case, I actually want to write it out myself. And the idea is that until the very end of this, this portion of the series, we're going to keep this old object so that we can compare with how it looked before and what we ended up with. Okay, this is going to be live. And now over here, we can actually also use live. And I'm going to remind you that this is actually a lambda, so we can call apply over here. Okay, but again, like it's kind of the same thing. It's actually very, very important to understand that you can mix and match, and this is going to be this is going to become actually very confusing because not only does ZIO provide this reader channel, which sort of like inverts things again, it actually offers you multiple ways to use it. It's going to be very, very confusing in the end. I'm going to try to like help you out, but it took me forever to actually fully understand like why it's actually necessary. But it actually is necessary, right? Like the cause for this entire complexity, it starts with this reader channel. We're still mixing and matching though, okay? So we need to actually arrive to the point where lives are only creating these basically not thugs, but like basically these functions, right? So every live needs to return a function, right? So this live returns a function. This one will return a function as well, right? So we're going to do lazy val live, and it's going to be, well, this one doesn't have any dependencies, but it needs to be a function. So we're going to write it in such a way that you could inject absolutely anything because the parameter is simply going to be ignored, and then it's going to return Google. Like this. Okay, how we're going to do this? Well, we're going to have anything, we're going to ignore it, and we're going to return make, like this. Very simple. Let's go and use it. It's actually right over here. So we need to call live, and as a reminder, it's actually a function. So we're going to do apply, and we need to give it something. So let's give it unit. Okay, so we're pretty much done. So we have the business logic live, we have the Google implementation live, and also this one also doesn't need anything anymore, so it's going to be any, right? And we're going to have like an underscore over here, arrow to the right, and everything else is going to stay the same. Now, finally, at the very, very bottom over here, we're not going to call make, we're going to call live. And again, it's a function, so we're going to do apply. I'm doing this on purpose, right? So that you're reminded that there is a function. Okay, we need to give it anything we want, for example, unit, or like it can be really anything. It doesn't really matter. Okay, some number, right? But let's actually give it unit so that it's more evident. One of the benefits of this approach is that we don't need to have this one central place where we assemble everything together. We could have a place where we assemble like a part of the graph and then assemble another part of the graph, and we provide the dependencies only partially. We're going to see something like this a bit later. Or in fact, I can actually show you a part of this now. For example, we can go over here and we can say business logic, right? So this is what I mentioned before, right? So if you go actually to business logic, right? If you try to call make, well, it's going to tell you that it needs Google, right? So you cannot call it if you don't have Google, but you can call live, right? Because it doesn't need anything, right? Because it's just a function that goes from Google to business logic, right? So you can kind of have these functions laying around and just compose them. In fact, what we have over here is already simply function composition. Let's actually show this. The same way as we used to have lazy val make old, right? The same way as we used to do business logic dot make, and we would give it Google Google implementation dot make. The same way we can do something like lazy val live, which is any to business logic, right? We could do business logic dot live, and then we can simply compose it with Google implementation dot live, right? It's exactly the same thing, and I did an equal sign over here, right? And it has to be live old because we're already using live. Okay, so if we go over here, we use live old, exactly the same thing is going to come out. Okay, and also you can do and then, right? So you can kind of like mix and match, right? So you can do like this and then this. right? So this is very, very functional. It's very, very kind of like standard in functional programming. Let me throw these guys out. Okay, and at the bottom, we're going to use live again. All right, now ZIO kind of tries to hide this functional thing, this functional programming for you. So what it does, it actually adds, right? We don't even have ZIO yet, right? It provides a DSL to kind of like toy around with these functions behind the scenes. Okay, we're not using ZIO yet, so we're going to use extension methods to make these parts pretty, right? So that we don't have to pass like these functions around. Like this DSL is going to manipulate these functions behind the scenes for us. So we're going to go to the bottom of the file over here, and we're going to create an extension. Okay, it's going to be extension for some function that is going to go from R to A. They're going to come from here. Okay, so it's going to be RA. Okay, like this, and it's going to have a function, and ZIO calls it provide, that is going to take the R, right? Let's make it a binary parameter. Okay, and it's going to produce a function from any to A, right? So it's going to be sort of like apply, but instead of like actually like applying the function and giving you the value A, it's going to give you the function that, given any is going to give you the A. Okay, it's very, very similar to apply. Okay, so it's basically, any comes in, and then we're simply going to run. Okay, so this is a teeny tiny extension method. Okay, so what it allows us to do is we can go over here, and instead of apply over here, and instead of apply over here, we can use provide, and we can use provide over here, right? And now this thing is turning into a business logic maker, right? So this is going to be a function, and therefore we don't need this. Okay, and this is also basically not Google. This is a it's actually C, the type is going to be inferred for us, right? So Google is any to Google. In fact, I didn't want to have it like this. I wanted to provide, but then I wanted to apply again, okay, like this. Okay, in fact, in this particular case, we actually don't need to provide, right? We can just do this. Okay, so this is actually Google, right? But this is the function that given any produces business logic, and therefore, as you can see, we're not actually dealing with this, underscore. Now, once we're going to start moving this thing into ZIO, ZIO is going to have helpers that would allow us to construct these things. Okay, so in fact, we're going to learn about the thing called Z layers, and they're going to have a function called succeed. For now, we don't have any of that, so let's actually go and add a global definition. So we're going to say succeed. It's going to be very silly because we don't have ZIO yet, right? So we're going to have succeed, and it's going to succeed with some value, right? Okay, it's going to produce a function from any to A, right? Any comes in, A comes out. Okay, like this. So now what we can do is we can go over here, right? So the idea is that we kind of like get rid of this underscore. Okay, so now we can just say succeed. Succeed was a make. What is happening? Like this. Okay, succeed. There we go. Okay, and the same thing over here. Well, actually, we cannot just simply succeed because this one actually has a dependency. So for this one, we're going to have another constructor. Let's go to succeed to the bottom. Okay, so this one is going to be called from function. And then once we're going to start talking about the layers, it's going to be called from service. Okay, so it's going to be a function RA, and it's going to give another function from RA. Okay, and it's simply going to call run. Right, so this is basically the identity function, right? So sort of like, right? It's simply going to return run again, okay? But for now, we're going to leave it like this, okay? So over here, we're going to say from function, which is going to look super unnecessary, right? From function, and then we're going to pass in the function, right? In fact, it's indented like this now, right? But as a reminder, it's like from function and then just make like this. In fact, maybe right now we can actually leave it like this, right? So from function make, over here succeed make. Over here, it's a bit more complicated. This is going to be a full comprehension once we actually gonna arrive at ZIO, and yeah, that's pretty much everything. So we finally arrived at the point where we can actually go and build it into our ZIO. So what we're going to do is, for now, we're going to comment out this entire example, and we're actually going to go back to this example over here. Okay, and we're going to see that once we build the reader channel into our ZIO, this program is not going to need to change because the reader slot is going to be inferred to any, and all of this is still going to compile. All right, so as of right now, this is a program that has nothing in the error channel and unit in the success channel. Okay, and then it's going to have a reader channel and it's going to be any. All right, let's go and do it. Okay, so now that it's going to be a proper function, it's going to have a proper parameter, we should probably not use the name thunk anymore, right? So we're just going to call it, like, I would call it function, but it's a convention to call it run. Okay, this is also why I called it run at the bottom over here. This one run, and this one run. Okay, so now this is a function and it's going to need another parameter, right? So this is going to be the reader, right? So reader error success. So now this is going to be a function that would take some R. I'm sorry, so this has to be the type, right? So it's going to take some R, it's going to produce the either E of A. Okay, now what we're going to do is we're going to simply grab these params everywhere, right? I'm going to press Alt F3 and they're all going to be marked, right? I'm simply going to replace them with R. Okay, so now there's this parameter. And in fact, I'm not sure, but this actually might be already enough. This actually might be enough, except for the places where we actually need to specify this parameter, right? So we probably need to inject the types everywhere. Okay, so over here, this is going to be a ZIO that has some R, and this is ZIO that, you know, where some R comes out. Same thing over here, R, same thing over here, R. Gonna turn into a pirate like this. R also over here. And we need to fix these guys, right? So when we're succeeding, it means that we don't need anything. Same thing was failing, and the same thing was in fact. Right, so this is how you know, the program in the main is going to still compile, right? Because everything is still going to be any, right? So ZIO succeed is going to be, you know, it's going to have any over there. Now in the console, I'm actually not going to annotate any types because everything is going to be inferred. And by the way, recently I started making everything lazy val, so let's also change this to lazy val. Now over here, it's actually kind of interesting, right? Over here, we're going to say that you know, basically going to hard code it to any, right? So you can give us a ZIO that, you know, it's going to take, you know, anything, and we're simply going to run it with unit. Okay, like this. Let's see if I've forgotten anything, forgotten something. All right, so there's an R over here. So this was just a mistake, you know, the copy paste. Yeah, there we go. So this was the only thing. Okay, everything still compiles, but now this is a program that, you know, it doesn't want anything. It might fail with nothing, so it actually can never fail, and it produces a unit. Now in the real ZIO, and this is one of the reasons why this was done, this default runtime, it can actually provide some things for you, right? So as of right now, you know, we have a very silly environment that doesn't provide anything, right? But in ZIO, there is a thing called a ZIO environment, right? For now, we're going to simply use a type alias. And for now, we're simply going to put unit over here, right? Because like this is what it's doing anyway. Okay, so what we're gonna do now is we're gonna go and inject environment over here. Okay, a little bit later, this is going to be something more, and we're gonna learn about it. Okay, so now if we're gonna try to save this, it's not gonna compile again because of contravariance issues. Well, before we had covariance issues, now we have contravariance issues because we have a program that doesn't want anything, but the default runtime expects something that can receive a ZIO environment, and currently ZIO environment is a unit, so we need to go and build contravariance in there. It's very, very simple. Right, and it's contravariance because this is something that comes in. Okay, so we're just going to put a negative symbol over here, right? So it's a minus. Now the compiler is going to complain, right? So we're going to do R1 over here, same thing as over here, but this was contravariance, and this is contravariance. So we need to use the arrow that goes into the other direction, right? So this is going to be R1, still going to complain R1, still going to complain R1, and now it's happy. We also have the flat map for the arrow channel that is called catch all, and it has exactly the same problem. So we're going to have R1. R1, okay, still complaining, R1, still complaining, R1, and there we go. This is it. All right, so now we can switch back, right? So we can comment out this, and we can also enable all of that. Right, so now we're going to rewrite this app in such a way that it's going to use ZIO, and for this we're going to need our helpers, right? Like these helpers. We're going to need provide that is going to be inside of ZIO. We're going to need succeed and from function that are going to be on the companion object. Now we already have this one, but we still need this one, right? So basically this was the factory method. Let's actually go and do this. Let me grab this guy. Let's go over here. Let's find succeed. Okay, so we had a factory channel for the we had a factory for the success channel. We had a factory for the error channel. We had a factory for sort of like both channels, right? If it's gonna succeed, it's gonna be for the success channel. If it's gonna fail, for the error channel. And now we need the factory for the reader channel, and it's going to be this from function thing, right? we're going to still keep calling it like this, right? So everything is going to change. That is going to change is that this is going to be simply a ZIO that receives an R, it produces an A, and in the middle, it's also not going to fail with anything, right? So it was a function from R to A. Now it's a ZIO from R to A, so to say. Okay, and we simply need to wrap this whole thing into ZIO. Right, and we also need to wrap this thing into a write because it's never going to fail, right? And this is going to be from function, right? Very, very similar. This is exactly why I created it over there. Okay, now let's do the same thing with provide. Now it was an extension method, right? Because it wanted to be in the scope that has this run thing, which is exactly what we have. We have a run from R to either, let me show this to you, from R to either an error or a success value. So we're going to grab provide just like the body of it. We're going to go to the bottom of ZIO, right? Not the companion object. We probably don't need this, right? Just over here, provide. It should be over here, right? And it's simply going to return ZIO, same as before, right? So it was like this. Now it's going to be ZIO, and it's going to be nothing A, like this. We're going to wrap the whole thing into ZIO. And because the type of run also already returns an either, this is actually everything we need, right? This is going to be sorry, what happened? Oh yeah, it's not nothing. It has to be the error channel, right? Because now we're inside of ZIO, right? So we're inside of ZIO, so we know our parameters, right? We know our R, our E, and our A, right? So now we're inside of provide, so it's going to be any EA, right? Very, very simple thing so far. So now we can go to main, and we're going to go over here, and now live is going to be a ZIO from Google. It's not going to fail with anything. Reduce business logic, and we're simply going to say ZIO dot from function. Okay, let's save it. Forgot the comma. There we go. Okay, same thing over here was live. Okay, so it's going to be a ZIO any nothing Google. Okay, ZIO dot succeed. Right, this thing now needs to be a for comprehension. Right, so let's fix the type first. It's going to be a ZIO any nothing comma business logic. Okay, this needs to be a for comprehension, which is exactly why I kind of like indented them like this. I'm gonna put the yield over here, sort of like this, which is kind of uncommon, but okay. Okay, so we don't need the vowels. Okay, the equal signs are going to turn into these errors. Okay, so now we're going to have Google implementation.live that returns a ZIO, so we're ripping out the Google. Okay, now we have business logic.live, and we still have provide Google. I believe this is actually everything that we need. Okay, so this is our for comprehension. Compare how it was before, right, with simple constructor dependency injection, and compare it now to how it is with ZIO with this reader channel, right? Again, like for now, it's super, super simple, but it's going to get very, very complicated towards the end. Now let's go down. All right. So now this entire program, it has to be inside of ZIO, right? We're doing ZIO now. Okay. So we don't need these guys anymore, actually. Let's throw them out. This entire thing is going to be in the for comprehension like this, like this. It's going to yield unit. We're going to save it as lazy val program. It's indented like this. All right, so we're going to not have the val. Okay, we're going to rip out the business logic from dependency graph.live like this. We don't need to do these like apply thingies. Okay, so now we need to go and do, actually I can do this like this, right? So this is going to be underscore error console dot it's put strln like this. Okay, so this is now a program, and what does it say? It says I found boolean, I required a string. All right, so in regular Scala, the print line, it can work with any type. In functional programming, we want to be a bit more strict. So if you go to console, we're actually going to see that we actually require a string over here. So we need to do it to string over here like this. There we go. So now we have our program, and now we can go and we can simply go and say runtime.default.unsafe run sync, and we're going to run the program like this. There we go. So now we're finally back at this same example, but now we're using ZIO. By the way, notice that usually like in functional programming, like this is not a functional program. Like we're using ZIO just for constructing the dependency graph, like for the construction of the dependency graph, but we're not actually using ZIO as like the return types, right? Like if you're familiar with tagless final, like usually you would want to return some effect type over here. And we're going to get to that in the next video. For now, that's not the point. All right, now this is all I have for you today. We're going to continue in the upcoming upcoming videos. But for now, as always, it's been Vlad from devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on GitHub sponsors or Patreon, and thus watch my videos weeks and sometimes even months before everyone else, including this series. And most importantly, take care.